We're going to be talking about the eIQ portal and the time series suite from NXP. So when you run the eIQ portal tool, this screen comes up. When you're using the time series selection down here, you do have to be logged into the NXP website to be able to have the tool work. So we're going to click on the time series studio button here, and we'll get that started up. Also in the background I have MCU Espresso, because we'll be using that for this demo. Alright, and it's talking about a new version available if you want to download that. Right now we're not going to do that. But when we get into the studio here, there's different anomaly detection scenarios, and there's some classification scenarios and regression scenarios, some utilities, and some solutions. So we're going to go over here on classification, and we're going to look at this fan state monitoring application, and we're going to have a scenario where we're going to load in some data that was already collected, and it's going to have 4 different classified states associated with it. The data set can be found at this data set button down here. It's in a zip folder, and here's a long path name that you would find the zip file located. If we double click on that, we'll have a folder for test and a folder for train. So if we go into the folder of train, we get 4 classification files. If we come over here to the testing, we get a similar 4 testing files with the same naming convention as the train and the test. So jumping back over on the eIQ tool, what we're going to do is we're going to create a new project with classification. So over here on the tasks on the left hand side, we're going to go hit classification, and we're going to create a new project here. And since we're doing a classification example, we'll just name it classification example. All right, and then we have to go pick out the target we're going to be using. We'll be using this MCXN947 Eval board with a micro-click shield on there with a couple motors on there. But we want to get the accelerometer that's associated with that particular green board there. So I'm going to come and click on the Freedom board MCXN947. In this particular example, we're going to have 3 channels of an accelerometer, and we're going to be classifying 4 different states of the data set. I'll just call this description class example. All right, and then we're going to confirm and create. Then the next thing we're going to do is we're going to add some files to these various data sets. So the first one, we'll hit the plus import, and we're going to find those files. Let me find those first. Okay, so I found the folder where the zip file was expanded. So we're going to go to the train folder, and we're going to get these 4 spreadsheet files imported. So we'll go, first one we'll do is train on when the fan is on. Okay, and then we'll click this top level check button to get all 20 rows imported and hit load. We also will change the name of this data set here. Let's see here. We'll say, I think it's fan on. Let me double check that. Okay, so we have the fan on. We're going to go import the second file, which is fan off. Select all 20 rows and load those in. Change the name of this data set to say fan off. Go to the third one. We'll get the train friction. Select all 20 rows, import those. Label that guy to fan friction. All right. And we'll go to the fourth and final file, which is a clogged fan, and import all 20 rows. Change the name. Whoops. We don't want to do that one. We'll change that one to fan clog. Okay. Also down here, we can see that we have like 4 different classifications of the data sets of the accelerometers, and up here we have 3 different channels of the accelerometer. You can come up here and change the scale and shut off some of the channels to view the data if you would like. Okay, so now we have the data sets loaded in. Now what we're going to do is we're going to click up here to the next. So we created a project, imported the data sets, and we're going to go to learning, and we're going to start the training of the data set, and we're going to do a quick search to try to find a model that best fits the data, and we're going to hit start, and we're going to let that run for a little bit. But as this is running, oops, okay, yeah, it's going to start to appear tick off over time, and as it's doing that, it's going to find some models that it's testing, and over here it shows you the validation results and the confusion matrix of the different classifications for the 4 different states. So we'll let it run for a while, and then after that's complete, what we can do is we'll select one of these models to use in our project file. Also, when you're over here on this side clicking a particular model, you can look at how much memory and flash and execution time and some other parameters, and you can see what the algorithm flow chart looks like. So you got some useful reporting for each of these models. So we're going to let this run for a little bit longer, and then what we'll do is we'll hit the stop button here, and we'll select one of these top models here that is fitting the data better than the other models. Okay, so at this point, what I'm going to do is I'll hit stop training, and we're going to click here, and we can see as we go through these models over here, your execution time will be changing. See, the R forest is 0.09 milliseconds. When we go to the SVM, we have 10 milliseconds different flash and memory sizes and stuff. So we're going to go with the rForest model, and then at that point we have data set that fit a model. And the next thing we're going to do is we're going to test the model with some other input data that would be more of a testing data set. So let's go and select a model for the rForest, and we're going to do a new emulation against that model. And here what we're going to do is we're going to go select the testing data sets. So the first one will be the on test, and then the second channel was the off test, third channel was the friction, and then the fourth channel was the clog. So basically we've got the different channels here, and once we get to that point, I think we're gonna start up the emulation. Let me check one thing first. Okay, now that we got the four testing files for the test data, we'll hit start, and it's going to start bumping that data set of the test off of the model data that we fed in for the train data. And let's see here. After we get done with that, we'll see emulation report, and it kind of shows the percentages of hitting the different classifications of the accuracies and stuff. So with the rForest model, we've got a pretty high accuracy of balanced accuracy of determining the four states of the fan here. At this point, we're going to we're happy with all this test data against the capture data set. We're going to go and hit the deploy, and then from there we're going to make a project out of this these files and make sure that we get the GCC and the float ABI selected. At this point, we can hit the generate button, and we're going to generate a zip file for the project, and I'll put that in my documents folder. And I'm going to change the name on that and put a 1 in front of it. I don't know if that's going to make a difference, but so we're generating a project, and then we're going to come over to MCU Espresso, and we're going to import a project where it says import project from file system, and we'll come over and do an archive and grab that zip file. Let's see here. So we'll go to my documents folder, and here is the 1 underscore that I just put in here, and hit the next button and finish, and it's going to load that into MCU Espresso, and you got to pick the SDK that works with the MCXN947 Eval board. Make sure that's loaded into your MCU Espresso. Once that gets loaded, we can come over to the project file, and in the source folder there's a hardware.c file. If we go to that and we look at In here, we're going to see a register HAL devices. So I'm going to click on that line. And what we need to do is we've got this register sensor HAL for this accelerometer. We need to uncomment these lines, and once we get that all uncommented, we'll be able to compile this project that we imported. Okay, and then what we need to do is, this is a dummy external definition. We'll comment that one out and save the file. Whoops, save. Let's close this one down. And then at this point, we're selecting that project, and we can build it. We'll see that it's going to be building up. And then what we want to do is down here, we're going to go and debug that project. And once again, we've got this particular eval board situation. And we see we've got a MCU link that's showing up, which is good. Okay, at this point, we're going to program the target, and we're going to be using, out of the dual core, we'll be using core 0. So let's see here. I was running this previous, so maybe I have to reset the eval board. Let me check that out for a second. Okay, so I had to delete the 2 projects out of my Project Explorer and import the zip file again. This is the second time that I was doing this example, so it got confused. But now I'm able to load the target, and I'm basically going to hit the run button up there. And before we do that, let me close and pause this for a second. I just want to make sure that my source code didn't get changed back to where I made my comments. Let's see. Yeah, so I got to change that back. Let me do that again. All right, so I had to recomment out some of that and changes that were required in the previous step. And now it looks like it's running. Then I'm going to hit the run button. And with the run button going, I'm going to bring up a COM port. And on this COM port, if you say help, you can see that the project file is loaded into the system. So this is completing part 1 of utilizing the eIQ time series suite software. The part 2, what we'll be doing is we'll be logging our own data set on the accelerometer. Not for a classification example, but more of anomaly detection on a fan or an accelerometer, difference in vibrations and stuff. Anyway, hopefully you like the video. Please like, share, and subscribe.